This section is on 6.1, System of Equations in Two Variables. There are three methods to solve for system of equations. So we're going to go with the first method right now. So the first method is called the graphing method. So you're going to be given two equations, and we're trying to solve for is the x and the y numbers for those. So the first thing you have to do in order to graph, you need to set it equal to y equals. So in this case right here, we're going to take the x right here, and well, actually it's probably going to be easier if I just go ahead and move the y over on the other side, because if I add y and subtract 5 on this side, so we're going to get as x minus 5 is equal to y. Then on this side right here, we probably want to bring the 2x over on the other side. Try to keep the y as positive, because if you have a negative, then you have to divide everything through with a negative, which is fine, but I just think that's an extra step. That's why. So let's bring the 2x over on the other side. So if we bring the 2x, we're going to subtract it. So we're going to get y is equal to negative 2x plus 1. And now we're ready to graph. So when we graph this out, the y equals, remember, anything that has an x, that's your slope right there. And anything that's a number by itself is called the y-intercept. So in this case, the y-intercept is at negative 5. So down here at negative 5. Let's go 1, 2, 3, 4, 5. So we're going to start right here on the y-intercept of negative 5. And my slope is 1 and 1. So I'm going to run positive 1 and rise positive 1. So from here, we're going to run 1, up 1, and then run 1, up 1 as well. So then from here, we're going to go ahead and graph this out. So try to use a straight edge. It's a lot easier if you do it that way. So here's our first graph, and I'm going to call this y1 because that's my first graph. So the second graph is then y equals negative 2x plus 1. So again, the plus 1 tells me where it starts on the y-intercept, which is positive 1. So in this case, positive 1's right here. And then my run and rise. So anything that has a whole number, I always put a 1. So the bottom is the run because you run on the ground and then you rise on the top. So I'm running positive on the x, but I'm going down negative 2. So from here, I'm running positive, but going down negative 2. So that's 1, 2. Do the same thing. Run 1, go down 2. Something like this, right? So right here. And so then from here, I'm going to go ahead and connect the 3 dots right there. Okay, so then from here, this spot where they cross right there, that is the solution. So in this case right here, the solution is about 2, positive 2 is the x number, and about 1, 2, 3, negative 3 is the y number right here. Okay, so that's called then consistent independent, and that usually gives us then one solution. So the one solution being this is the x number right here and this is the y number. So because there's x's and y's in these equation right here, we're trying to solve for is what is the x value and the y number for it. So that's one way to do the solving for that is by graphing it. Okay, then let me also go over the different types of graphs, because there are possibilities that you'll get something like this in a graph where the two equations, when you graph it out, they go parallel to each other like this, but they never cross over, so which is okay. But then in this case, there is no solution because obviously they're not going to cross. So when they cross like this, wherever they cross at the intersection right there, that is the solution. So in this case, because they don't cross, right, because they're parallel to each other, just like train tracks, then that will become an inconsistent independent. That's what the name is called, and there's no solution to that. And then there's also this type of problem, which then says that actually both of the equations are exactly the same line right here. And in this case, we call it consistent dependent, but there's also many solutions. Many solutions, the reason being is because if they're on top of each other, every single intersection, right, that they're intersecting, because they are intersecting since they're on top of each other, those are all solutions right here. So since there's many solutions, we call it many solutions or infinite number of solutions. Okay? So with the graphing methods, there are some tricks to that. You have to figure out is it going to be one solution? Is it going to be no solution? Or many solutions in that case? All right? So that's one thing. The other thing is called the substitution method. So the substitution method is pretty much what it is. So I personally don't like when people call it plugging in, because there is no plugging in method. It's substitution method. So when you do this, you're substituting either a variable of x or a variable of y. Okay? Now, when you do the substitution method, there is no literally a way or step to do this. You have to choose what you're going to substitute in. So normally, I'm going to call this equation 1 and call this equation 2 so we won't get so confused about this. So in equation 1, you have to decide, are you going to change that equation up so you will substitute it into the equation 2, or vice versa, you can change up equation 2 and then substitute it into equation 1. Now, the only trick I would suggest is that look for something that has a coefficient of 1. So for example, in the coefficient of 1 in here, the x right there, the number in front is a positive 1 right there. So that's a possibility right there. The coefficient of this is negative 1. Now that can be a possibility, but remember there's a negative in front of it, so you may have to divide everything out by negative. The coefficient of this x right here in the second equation is 2. So you may not want to go with this one, just because if you do, it's not wrong. You're going to get fractions though. So I'm going to forewarn you that you will get a fraction if you have a coefficient other than 1. And then the y right here has a coefficient of 1, so that's good. So positive 1. So it's either a choice. You can either take your equation number 2 right here, fix it up so you get y by itself, since that's a coefficient of 1, or you can take your first equation right here, change it up so you get x by itself, right? And then you're going to substitute it in here. So let's do this one right here. So we're going to go ahead and get x by itself. So to get x by itself, I have to bring y over to the other side. So we're going to get x is equal to, and then 5 plus y. Now leave this alone. Some people may even box it or circle it, because you will probably come back to this equation right here. So I'm going to go ahead and circle it, because we're going to probably come back to this part right here. So I'm going to take this now, and you cannot substitute it into itself again right there, because then you're going to get undefined or 0 or something like that. So you don't want to do that. Whenever equation you fix up right there to get x or y by itself, then you need to substitute it into the other equation. So in this case, this is the other equation. So since this says x equals, we're going to substitute this x right here with everything that's inside here. Okay, so what does that look like? So then it's going to become 2 parentheses 5 plus y. I substituted all of this x right here, because it says x right there, into that, plus, and then we keep the plus y equals 1 right there. Everything still remains. Okay, did you see that substitution? So this is why it's called substitution. You're going to substitute all of this in place of this x right there, just like this. Okay. So then the algebra begins. So then you're going to go ahead and distribute the 2, right? So that's going to give us 10 plus 2y plus y is equal to 1. And then you can see now you only have a variable of y, which is what you want. You only want one variable. So if you have a variable y, obviously you're going to be solving for y. So we're going to go ahead and bring the 10 over on the other side and combine my terms right here. So that's 2 plus 1 is 3, so that's 3y is equal to, and if I bring the 10 over, it's minus 10, so 1 minus 10 is negative 9, right? So then y is equal to negative 3, okay? So we found one of the answer, which was y equals negative 3, but we have to solve for x. So where would we put this? Well, this is why I circled this up here, because now you can take this and substitute it into right there in that spot right there. Okay, so if I substitute that, what does that look like? So it's going to become x is equal to 5 minus 3, right? Because now we substitute the y number as negative 3, so which is that negative 3, so x is equal to 2. Okay, but your final answer, make sure you write it in coordinates, so it's 2 comma negative 3 like this. So this is the final answer right there. Okay, the reason why it's coordinated, because remember, we could have done this in the graphing method. So you could have taken this equation right here, change it to y equals, change it to y equals, graph it out, and found the intersection, and they should have intersected at 2, negative 3. Okay, so that's one method. And then, so then the last method is called the elimination method. So the elimination method is what it says, it's eliminating. So what your goal is to do is either to eliminate the x variable or the y variable. One of those first, and it doesn't matter. So you want to try to eliminate something so that way you have one variable, similar to what we did right here. We have one variable right here, we can solve for it. Once you solve for it, then you can go ahead and substitute it into the second or the first equation that you didn't use to do that. So let's see, what should we eliminate? Probably let's go with the x, just because I think the x would be easier. So let's do that. So in order to eliminate the x, we're looking at the 4 and the -5. What I'm looking for is the lowest common number between them, right? So the lowest common number between 4 and 5 is going to be a 20. So that means I need to multiply everything on this side by 5 to give me that 20 right there, right? And then I multiply everything on this side with a 4 to give me that 20 right there. Now, you will have a -20, which is fine, because that's what you want to do is get rid of it, okay? So once I get this number right here, the coefficient for that, then we're going to go ahead and distribute that in. So we're going to get 20x plus 15y is equal to 55, because 5 times 11. Don't forget to distribute that last part. That's where a lot of people forget, is this last part for some reason. They always remember these guys right here, but they always forget this part right here, which then will give us a totally different number. Okay, so then distribute the 4 now. So that's going to give us then -20x plus 8y is equal to 60. Okay, so now this is now the new equation I'm going to be working with. I'm going to ignore these right now. We're just going to go ahead and do this. And what we're trying to do again is to eliminate. So to eliminate it, I'm going to add is these number right here. Because this is +20 and this is -20. So you have a control out here, whatever you want to make this a plus or minus. If both were +20, I would have to do a minus out here in order to get rid of it, okay? So since this is positive, this is negative, I'm going to go ahead and add it. So this cancels out to a 0 right here. So now you have is 15 plus 8. So whatever you choose out here, make sure you use it throughout the whole rest of the problem. So 15 plus 8y gives us 23y. And then you have 55 plus 60, which gives us 115. And so then you have to divide by 23 on both sides, and y is equal to, I believe 5 is going to be the answer. Okay? So now once I get y equals 5, I can go back and substitute that into either equation 1 or 2. So I'm going to go ahead and forgot to put 1 and 2 over here. So 1 and 2. So you can substitute either one of those equations. Now you can always go back to here and do your substitution, or you can go back to here and do your substitution. I always go back to the original just because then the numbers will be smaller. Remember, these numbers right here are larger just because we multiply them, so I always go back to here. Now, when you do the elimination method, since you eliminated both the x's, right, it doesn't matter if you substitute back into the equation 1 or to equation 2. And again, always look for something that's small so that you don't have to deal with so much with the bigger numbers. So I'm going to go with the equation 1 just because the original equation of that is 4x plus 3y is equal to 11. So I don't do this 5 right here. I ignore that, and I just go back to the original, and I'm substituting this part right here, the 5, into this part right here. So then we have is 4x is equal to 3 times 5 is equal to 11. So 3 times 5 is 15, right? Plus 4x. And so we're going to subtract 15 on both sides. So x is equal to minus 15 will give us what? -4. And so if you divide both sides, x is equal to -1. So then final answer is -1, and 5 is the final answer, right? Because that's your x value right there, and this was the y value over here. Okay, so we just put it together, and that becomes the new x and y. Okay, so go back and review the video if you have any questions on any parts of the methods.